Okay, it's recording. Good morning, Sam. Shane. Picture's worth 1,000 words. I thought, hey, I'll take a quick video, and that way I can get some text and context at the same time. So I was just sketching some basics here. If I remember right, you have two rails. If we go with a table style, which that seemed to be what you were leaning towards, or I took it that way. I think that makes a lot of sense. I'm trying to envision myself being the one who's using these and building trusses. I think it'd make great sense. You take a basic, whether we build it as a 2 foot by 4 foot, obviously it needs to be approximately the 4 foot for between your sets of tracks. I guess that's up to you. 2 foot by 4 foot, we could allow the tops to cantilever out over. We could still go with a 4 by 4 top, or maybe you just want to stick with a 2 by 4 top. I don't know what that would mean to your guys. 4 by 4 would obviously be a lot more stable. I'd keep the frame real basic. This is not a final detail. These are all just real quick sketches to get something worked out for you. Obviously, we're early in the quoting stages, so I don't want to burn up too much time into it, and I want to see where you're feeling to go down the proper direction on the road. Keep something basic, a simple stud out the side for putting a wheel on so that it mates up with the rails, and then whatever braking system or assembly we need to use. We could also, when we build you the table, the one benefit I thought of was possibly either a shelf underneath, or you could even get into maybe a small hopper on the side. I don't know what kind of supplies your guys need while they're working. If they're using gussets, maybe that's a great storage area for keeping your guys efficient. Fasteners, whatnot, tools. So yeah, just a basic frame, and we could work out the details as far as locations of the weld points and the actual dimensions. It's neither here nor there at this point. Casters. For a wheel system, we could either go with a cut wheel, cut something to shape that would match the groove and dimension of your unistrut, or we can buy pre-made casters. That's definitely going to be the more cost-effective point. Just buying a slug of 4-inch steel is going to, even mild steel is probably $60 a piece without even cutting them or putting a bearing in yet. We can buy a cast iron or cast steel caster with bearings in it for $50 from McMaster, or we can get a black plastic for as low as $15-20 a piece. I don't know where you're feeling with that. Obviously, that's going to make a substantial difference, times 4 per cart. You're at $80 versus $200. So where would you want to go with that? The plastic ones, we're looking at about an 800-pound load capacity per each. So I don't know where your total load's going to be on this with your product that you're building, your trusses, as well as the total weight of the unit. Getting back to the total weight, you were talking about using, if you do this, obviously you want to put a series of holes in, and use some sort of a cam locking clamp. I don't know what thickness you need there, 1/2 inch or 3/4. I'm guessing probably not less than half. 3/4 would seem to me ideal. 3/4 inch or 1 inch brings up the weight issue. Okay, so a 4 foot by 4 foot platform at 3/4 of an inch is going to weigh you about just under 500 pounds. If you drilled your holes at approximately a 2 inch by 2 inch pattern and used a 1/2 inch hole, you're only going to save about 22 pounds. You're pressing that 500-pound mark for that top. If you use the solid steel, again, that's a solid steel 3/4 of an inch. My thought was the possibility of using a sandwich. So maybe you'd start with an 1/8 inch top, 1/8 inch bottom, and compressed MDF filler, something light, some compressed wood, or maybe even some plastic. The reason for that being that your clamping forces, the pressure is going to be at the low spot and at the high spot. I don't know if this would work for your application, but it definitely would make a huge difference on the weight. Again, if you made an 1/8 inch sandwich with an 1/8 inch top, 1/8 inch bottom, 1/2 inch in the middle, that's a total of 1/4 inch worth of steel on your top, and now you're down to 163 pounds. So from a weight standpoint of your guys pushing or moving these around, that might be beneficial, even just, say, for example, freight to get it down to you. That might be a savings. You're not going to be a real huge savings, I think, money-wise. You're somewhere in the vicinity of $250 for a 4x4 blank of 3/4 inch steel. Until I get 2 layers of 1/8 inch, you're going to be at, give or take, about $200 just for the blank steel, without any holes or any machining on it. So I don't know that I would look at that one as a cost standpoint, more a versatility and a weight standpoint for your guys. Also, it would save some drilling through 1/8 inch versus 3/4 of an inch of steel. That would save us some machining time. All right, so then we'd also need to determine what pattern. You didn't, I don't know that you specified, I don't recall if you did, as far as the pattern of the holes, your spacing. Is it a 2x2, is it a 4x4? 4 inches by 4 inches, is what I mean. So we definitely need to talk about that, get an idea what kind of time we're going to get into to get obviously a hard number. Then there's the braking mechanism. Now, trying to think intuitively here. I don't want to overthink this or at the same time underthink it for you. I know you've got a system now which I understand is a foot pedal, so the brake is either unlocked or locked, and your operator locks it into place by means of pushing down on it, and then it stays locked until he does something. I didn't see your mechanism though. I don't know if we'd be able to get away with locking the wheels themselves. If the top is heavy enough, if you go with a solid steel top, you may just be able to use a simple wheel lock and lock the wheels. Or we could do similar to what you had before, which I think is something along this lines. You've got this shaped shoe that is, whenever he depresses or presses the pedal, it locks it in place. I had a thought of utilizing a lever system. Think of a lawnmower, the safety stop for your push mower. The brake would have a spring somewhere in the system, probably out towards the handle, that keeps constant tension on the shoe, so that the brakes are always locked until your operator is ready to move them. So in essence, he would be standing along your table here, and he would push down with his hand, and that would unlock the brake, slide the table to wherever he's going to slide it to, and release his hand and release the brake. That sets your brake. Your brakes will always have a constant pressure, so you're never going to have any operator error, whether it be your operator forgets to set the brake or your operator oversteps on the brake pedal, let's say, the lever, and bends it, and etc. So I think there could be some benefits to a system like that. In essence, you'd have a bar maybe that with hinges here, and your operator, if this is your main operator side or the outside of your table, let's say, he would push the handle down here, and the handle rod may come down through the framing here underneath into your unistrut. I think a system like that, I kind of like that idea. You may or may not. You can let me know, and we'll work around whatever it is that you want. If we go with the caster style wheel, back to that, we would need some kind of a guide, whether it be a simple chunk of steel welded down in that slips down into the rails to keep your tables on track, or we could possibly rely on your brake as that. If you've got a brake that sits down into your unistrut, obviously by limiting the total amount of the distance that it can travel down, so that it never travels past the sides of your rail, if that makes sense. You could possibly use that as your guide to keep it on track. Your typical steel caster is going to have probably the least amount of traction, so that's going to make it easier for your whatever guide system we use to help keep it in line. A plastic wheel may have a little more bite by biting into whether it's nicks in the paint, etc. But there again, the other option would be to go to either a wheel that we could buy with a shoulder on it. You're probably going to see about $60-80 per wheel if we get into that. But then other option being going back to a cut wheel. I don't know that we even need to go down the road of a cut wheel. I'm just tossing that out there for you. If we would use the brake, I'd call this the brake shoe now. If we'd use that brake shoe as the guide, I think you want to make it a little longer, maybe 12 inches or so. There again, I don't know how you're set up down there to be able to slide those in from the end and assemble these tables as you mount them on, whatnot. Back to the top here, we could build the tops as one solid piece of 4 foot by 4 foot. That makes it a one-piece top, less machining. Or we could cut these out as a, let's say a 1 foot by 4 foot, or maybe even 16 inches by 4 foot, which would give you 3 segments. The benefit to that would be that down the road, let's say your guys tend to operate in this area on the table for whatever reason, and you very seldom use this area of the table. By cutting it into segments, you could make these segments reversible both directions. You could rotate them end for end and now have a new set of holes, or you could even flip them over and again have a new set of holes. So that would give you a long service life. Whereas if your guys tend to work in this area of the table, because maybe that's how it tends to work out with the measurements of your trusses or where you put the gussets and webbing, then you're limited to, again, how many times you could flip and rotate. We can always align our holes in such a way that you can flip and rotate your surface regardless of the size, but by making segments, it gives you more versatility there for a service life. Again, that's not so much even a material factor for the cost of the material, but that does make a difference on obviously having to drill more holes and making sure that things are all aligned so that you can, in fact, reverse them and interchange them with each other. Even down to being able to change one from this table versus another table in your system could be of value to you. That's up to you, again. And then just obviously countersunk screws into the base. It's really simple. If we go with a 4 foot, I think you're going to want to put a support in the middle. Again, that's a minor detail. So that's kind of the basics of what I've got in mind and what I'm thinking for a design on a table. Again, there's a lot of variables there as far as how do you want to go about the braking system. My thought would be to build one table. I'd set up some unistrut, make sure and get me the dimensions on the unistrut that you have so that I can get something that matches. I'll set myself up a temporary unit here to design and build your first table off of, ship that table to you, and then you can give your pros and cons, let your guys use it, so forth, and get back with me if that's something that you want to do. And if we end up doing business together, that's probably the way that I would want to go about it. I'd rather not make, is it 12 or 24? I'd rather not make 25 or however many tables that are wrong for you, obviously. Okay, from a costing standpoint, I'm picturing your base unit, just your main frame and base, painted with your studs. I call your axle studs, probably in the $300 mark, maybe $500. I would say if we're ballparking it, go $3 to $5. I realistically think if we keep it nice and simple, $300 should be real accurate. If you want to get into adding whether a storage shelf down here or a hopper or a tray or something somewhere, I think that still keeps us within range. We could even put you just the framing brackets, and you could put a wooden shelf down there. It doesn't need to be made out of the same steel as on top. Again, that's a conversation for down the road. So your base frame, probably $300 to $500. Then where do we go with the casters? Do we go with the plastic casters at $100 a piece, or $20 a pop, or do we get into cast iron? Where do you want to go with that? Obviously, $50 a piece versus $20 a piece. Makes a couple $100 difference on that. So you throw a brake system on the casters. I think we're looking at somewhere between maybe $800 to $1,200 on the base with wheels and the brakes, and then get into the top. Again, are you another $500 into the top? how many holes are we putting in, all of those variables. Obviously, a 2-inch by 2-inch pattern is twice as many holes as a 4-inch by 4-inch pattern on your drilling. So I would need to know that before I'd get too hard of a number in. I'm thinking realistically on a low number, something real economy, basic. We keep the design simple and usable. I'm thinking $1,200 to $1,500 per unit on a low number. I'm probably going to end up close to that 15 realistically. As a high number, 18 to 2,200. And there again, do we get a shelf on the bottom yet? How do we go about that braking mechanism? You know, I'm thinking if you'd run you could run that handle mechanism where you're going to probably need to brake on both sides. You could even do that by means of a handle on this side that runs across and back onto this side, so that it's a one handle in the middle, unlocks both brakes for both sides. Maybe you tell me that you only think you need one brake on one side. Hey, we'll do it from that angle. But I think that's pretty healthy of a number range. That gives us some room to have conversation with and walk down the road and continue on talking on Tuesday. You get into your clamps. I don't know what, we never had much discussion on that. That's obviously something that I could build as well. I don't know if there's something on the market that is already, someone else has come up with a design and already works with your dimensions for your gussets and so forth. I don't know what you exactly need there. I have my idea, but that may be far from reality. I don't know. But it would be something with a clamping bracket out here. You could make something with a little lever cam out here, or maybe a big wing nut. There's a million and one options. How simple do you want to keep it? How inexpensive do you want to keep it? In building something real basic like this, I can imagine something in the $25 to $50 range a piece. Do you want to build them out of aluminum so that they're nice and light? If aluminum is strong enough for the amount of clamping pressure that you're using, maybe a steel stud for your base, and then maybe an aluminum bracket. The leveraging bracket could be out of aluminum, where your main meat is of material. Keep it light. Again, strength versus weight and cost factor for you. Aluminum is a little easier to machine, but it may not have the service life that you need. We can have some conversations down there. You had not necessarily requested that, but I know that's part of this whole system that you're trying to implement for your shop. So obviously I'd be glad to make something along those lines as well. All right, I think that pretty much sums it up. Again, you can get a picture for the weight. These things, probably no matter how you dice it with your frame, your wheels, and your top, you're going to be in the vicinity of about 300 pounds. I would guess 250, 300 pounds. If you go with the solid steel top, 3/4 inch solid steel, or it's even going to be heavier if you go with 1 inch, obviously, but you're probably going to be in that between 500 and 800 pounds, probably close to 800 pounds, 800 pounds with a solid steel top. So now your guys are carting that 500 pounds. I mean, from a design standpoint, I think the table is a better idea than the pedestal stands for a couple of simple reasons. The work area in this, as well as the clamps, yeah, I mean, to me that makes a lot of sense. The idea of a short wheelbase, like the pedestals you currently have, where you've got your two rails and what is it, a 1 by 1 foot base? And again, I don't remember the spacing between your sets of rails. I know they're 4 foot on the major. I don't know where they're at on the minor point. But just that just seems like, you come up 3 foot or waist high, 2.5, 3 foot, but then you've got a small base. That's a lot of leveraging and racking and etc. And I think that's just another wear factor. You're going to find that in 2 or 3 years, you're probably not as satisfied as something like this. There again, I don't know. I've not run your operation. Your guys in the field might might be the best resource for what's the best application here. Again, we could build you one table. If I do a one table thing, I might have a little higher cost factor into just that individual table for an initial test. But then I'd want to get you a sample of that, let your guys critique it, set it up on your racks. You know, maybe you could run that as in with your integrated with your pedestals for now, and get some feedback on it. Make notes, make some changes or corrections or alterations, and then if you'd be ready to move forward, go ahead and make the remaining quantity. So, all right, I'm gonna check out, and I'll shoot this to you in an email, and hope it finds you well. Thanks so much. Bye.